in the Ascii chart, the character would be listed in one column, and then the decimal value that matches that character, like pretend each one of these are keys on the keyboard. The decimal value is here, and the hexadecimal value is here. The letters all start at hexadecimal value 65. The lowercase version of those letters is 32 beyond that. So, if I can bring my la-di-da back up, let's get this up at the very top if we possibly can. Okay. Now, I don't know if any of y'all can actually see, but what is an I? Here's an I. An I is a decimal 73. And then an L, well, a space. What is a space? We have to find a space. Here it is. A space is a 32. I'm going to go ahead and put spaces between everything just to make it easy to read. A L is a 76. And an O is a 79. And a V is a, okay, we get the idea. Instead, let's do it in hexadecimal now. So I'll just do it out to the side. An I in hex is a 49. And I know y'all in the back of the room can't read this, but you get the idea. A space in hex is a 20. An L in hex is a 4C. And an E in hex is a 45. And you're going, yeah, big deal. Well, it is kind of a big deal. Whenever you type anything into the computer, it gets translated into numbers like these to be stored in memory. If we ask for input with CIN and you typed in I love C++, then if you looked in memory, you would see a 4920-4C45. You'd see them without spaces. And then if you boiled it down to bits rather than bytes, you know, you'd see 0010, 1111, you know, you'd see all those. That's really about enough. 45 was a what? I got lost. I started chattering. 45 is a E, so what's another space? What space? Yeah, it's 20. And then we could keep going on. So we could prove that that's correct. I may have shown you the site hexedit, hexed.it. We're going to create a text file. All it says is I love C++. Heck, we can just use this one right here, but I'm going to put this on a line by itself. When we look, we're going to see that there's actually something between that period and the 4. We're going to see new line characters. We're going to see /n, except /n is not /n. It is the new line. Well, there's a carriage return, so we'll either see a D, or we'll see an A, or we'll see a combination of the two. Different operating systems use different combinations of that. Good old DOS used 0D, 0A. Macs, I think, just use 0A. Linux just use 0D. I'm not sure what Windows Notepad uses. We'll find out real soon. So I save this. I'm going to call it I love C++.txt. And then I'm going to upload that to hexedit. So I go to hexed.it. I do open file. There we go. That looks real bad. That's not what I was expecting to see. Oh, there was a bunch of other junk in there. It was the answers to the quiz. Okay, I need to move this up to the top. Now I'm going to re-upload it. here we go. We see I love C++ in our little hex editor here. And I really can't get this to zoom in, unfortunately. Maybe I can with this. That's about as good as I can do. But I is a 4-9. A space is a 20. An L is a 4C. An O is a 4F. A V is a 5C. An E is a 4-5. A space is a 20. And we can change these. If we go back to our Ascii chart, and instead of a space between everything, we want to see question marks. I just need to find question marks on here, wherever they are. Okay, here they are. They are 3F. So I can come back here, go back to hex edit, change this space here that I'm sitting at to a 3F. And if we look over here, now there's a question mark. And if I do export and I save this back and I go edit it, then that space really did get changed to a question mark because I changed the hex value of it. So this is how text is encoded in ASCII. Now Unicode is a 16-bit rather than 8 bits. So it's not stored in bytes, it's stored in double bytes. So if we were going to encode this in Unicode, then it would look like this. Each one of them would be separated by zeros. But Notepad doesn't create Unicode documents. Unicode creates text ASCII documents. So that's why it didn't have those zeros in it. So go out to your Dropbox. There should be a Dropbox called ASCII Hex, and if you open it, and I apologize, you 1113 users, you probably will recognize this, but just think how easy it'll be this time. Go and grab the document out of it. It's called ASCII Hex Conversion, and let's just work on this together. Okay, example, using the Ascii chart. Oh, there's one thing I forgot to look at. I said I was curious how it handled new lines. Let's go back here. Where was the end of our line? We had I love C++, then we had a period, and then we had a new line. Okay, so our period was a 2E, and then the new line was represented by 0D, 0A. So in our worksheet, when we have to go to the next line, let's add a 0D, 0A to it. Okay. So using the Ascii chart, convert the following text to a series of hex numbers. Cab, Uber. Well, an uppercase C, we would scroll up here. It'd be easier if this was 2 windows, wasn't it? Is a 43, so we would write 43. A lowercase a is in the next column. It's a hexadecimal 61, so we would write 61. A B is one higher than an A, so we would write 62. Now we're skipping to the next line. So a new line is a carriage feed, a 0D, followed by a line feed. Because in olden days, if you sent a 0D to the printer, it'd send it back to the beginning of the line, but it wouldn't actually roll the platter up. So you had to send both a 0D and a 0A to the printer. And that's why DOS does that. That's why Notepad does that. And then Uber, U-B-E-R, and then we're pretending that there was another carriage return line feed, another /n at the end of Uber, and so we recorded those there. So, homework assignment 2. Convert this ASCII text to a string of hex numbers. And there should have been a box here for doing that. To make it easier, you might grab the Word document, slam it against the side to dock it there if you're using Word, and then go to Google and look up an Ascii chart, and then you can kind of toggle between the two more easily. Just dock that one on the other side like that. Maybe it'll make it easier. Otherwise you have to do a lot of scrolling. But on the other hand, you can lower the size of your text more than I can. So I'm going to work along on this while you do it as well. Remember, when you go from one line to the next, tack on a 0D and a 0A. And then on the next page, there's one where you do the exact opposite. You take the hexadecimal numbers and you turn them into ASCII. So a 50 in hex is a P, capital P. A 72 hex is a, and you just look them up. If you get tired of scrolling up and down to see your ASCII chart, you can always make a copy of it and paste it right above the problem that you're working on. You know, I forgot what this is, so I'm kind of stymied. Now, if I give you homework like this, or it's on an exam, I don't want you to pop open hexed.it and just type in programming is fun into the little window and then writing down the numbers. I want you to be able to do it yourself. But I promise that on the exam, what I'm probably going to do is just give you several choices to pick from, rather than make you do it letter by letter, because this actually takes some considerable amount of time. And so it'll be blatantly obvious which one is correct. So who's got the first one done? Raise your hand. Let's go ahead. Why don't you read off the numbers? I'm going to do new file. And tell me the numbers to type in. Somebody go.
52.
52. What's next?
6F.
6F.
73.
73.
65.
65.
0D.
0D. 0A.
53.
53.
74.
74.
61.
61.
74.
74.
65.
65.
0D.
0D. 0A.
52.
52.
6F.
6F.
63.
63.
6B.
6B.
73.
73.
20.
20.
21.
21.
0D.
0D. 0A. Alrighty. So, looking at that, it says rows, then new line, state, new line, rocks, with an exclamation mark, and then a new line. That makes sense to everybody? Hope so.
Capital P.
I think you started using the decimal and hex columns. Yeah. Maybe it should have made these sentences a little shorter. Looks like something completely different. That's okay.
Here, hang on for my cup.
Okay. Will do. Excellent. Awesome, awesome. I hope you totally agree, considering that you're taking the courses.
We're almost there.
Yeah, yeah, almost there. In the little spaces on the document, I should have edited those out. This little space right here, you don't have to put a space in your answer there. Otherwise, it's going to wind up saying program space Ming is fun or whatever. Everybody has the idea. The answer to the second one, if you didn't quite get it done, is programming, new line, is, new line, fun, exclamation mark. Doesn't look like I tacked on a new line at the end of this last one. My mistake. I would have. I'm not going to go to hexed.it and verify that everybody had it right on their documents. The only thing you have to watch out for is that since this shows both decimal and hex, it's easy to get your eyes crossed. And when you're looking up 50, you might go, okay, a 50 is a 2. And then you might look up 72, and you go, well, a 72 is an H. And then, you know, so if it doesn't look like a word, then go back and double check, make sure you're in the hexadecimal column. Alrighty. Go ahead, save and upload that to the Dropbox. Okay, we were talking about identifiers. Identifiers are variables and function names, and then when we introduce the idea of classes, they are class names. The general rules, which most texts follow, is that you want to start all your variables with a lowercase letter. All your function names should start with a lowercase letter. There are exceptions. If you're going to define a constant, most texts recommend that you use an uppercase. And so what is a constant? A constant is just a variable that cannot be changed. Its value, once assigned, is fixed. And if you try to write code that changes that value, you won't be able to. So I'm going to open a recent project and just delete what I already have in it, rather save myself time. Let's talk about the different places you could put variables. You can declare your variables right before you need them. So say we were going to write a temperature conversion program, where we said float temperature in C, TEMPC, is equal to 50. And now we want to convert that to Fahrenheit. Fortunately, the formula for converting to Fahrenheit is not too bad. It is, if I recall, F is equal to temperature of F is equal to the temperature in C times 1.8, or 9 over 5, plus 32. And then we can see out that information. Temperature in C temperature F, like that. Okay. So this program uses two variables. These are called local variables. They're local because they're inside the function which needs them. There are other places they could be declared. We could cut those out and put them out here. Now they're called global variables. Global variables aren't really the best thing. They're not really approved of in modern programming, but that's because modern programming embodies the idea of class object-oriented programming. And we haven't hit object-oriented programming yet. So at this point, global variables are kind of okay. This would work. If I run the program, let's prove that it works before I say so boldly. And it didn't pause. I didn't get to see the output. System. Pause. Alrighty. 50 degrees C is 122F. That sounds right, but I'm going to change the starting point to a number that I absolutely know is correct. Freezing in Celsius is 0, and freezing in Fahrenheit is 32. So I'm going to change temperature C to 0, and then when I run it, it should say that the 0C is 32F. Okay, so that's working correctly. It worked regardless of whether these variables were declared globally or locally. Why would you declare variables globally? Because then they can be accessed by more than one function in the same code. And I'll give you an example. Let's make another function. I don't know what I'm even going to call this function. I'm going to call it I don't know, because I'm not coming up with a good purpose for it. But now I have a function called I don't know. Oh, I tell you what. Let's make the output function. There we go. And we're going to move this line that says cout up to a different function. Now the text hasn't shown us functions yet. But the idea behind a function is that it's just a different block of code. One or more lines that has a different name. It's not main. It's stored in another function name. So we have a new function now called output. So our source code here has two functions. And the way it works is that when C compiles it, the launching point for the program is always going to be main. But as main goes along, it may call other functions. So what happens here? Temperature F is equal to temperature C times 1.8 plus 32. Given a starting point of 0, when this is done, temperature F will equal 32, because 0 times 1.8 is 0, plus 32 is 32. And then it calls the output function. Well, what happens then is the little internal pointer in memory that says where our code is jumps up here and executes this line. And so it would print out temperature C, which was 0, is, and then it would print out the new value of temperature F. Now temperature F got reassigned to the value of 32 by this line. So it would print 0C as 32F. Prove that it worked. I think we already did this once. There we go. 0C is 32F. If this was not declared globally, this would not work. If I move these down here back to where they were, like that, this code won't even compile. Why is that? Because these variables are local. It's like a sofa inside your house. The house next door can't use your sofa because these sofas are in the house. However, if we carry our sofas outside, then everybody in the neighborhood can access them. Both functions can use them. I'm quite proud of that simile, that metaphor. Okay, I hope that makes sense. I could fix this if I wanted to in a different way. If somebody's had another programming course, they probably know how I would fix it. How would I make this function capable of printing out temp C and temp F? Did I hear the answer? Pointers, parameters. I could pass these in. The way you do that looks like this. And we're getting a little bit beyond, certainly, where this program, where this chapter is talking about. But I want you to see this stuff. Okay, so the idea behind a parameter is that it is a variable defined within the parentheses that define the parameters of the function. So when output is called, we have to pass in a temperature C value. And we have to pass in a temperature F value. And whatever we pass in gets printed out, because whatever we passed in here gets used there, because that's that variable name. And whatever we pass in here gets printed there, because that's that variable name. Notice that it's even trying to do some subtle highlighting. When I highlight temp C here, it kind of puts a gray around that. When I highlight temp F here, it puts a gray around that. If I passed in something else other than these variables, it would still work. Like if I passed in 1,000 here and 500 here, that works. I mean, it's not the correct answer, but it works. It would print 1000C is 500F. Why is it doing that? Because I passed in 1,000 in the first parameter, 500 in the next parameter. So when the output function is invoked, it runs up here, and this little variable here, defined between the parentheses, gets the value that was passed in, 1,000. And then this variable gets filled in with the second value that was passed in, which is 500. So it prints 1000C is 500F. Then it returns back down here. So parameters are a way of getting data into functions. It's a more recommended way of doing data sharing than using global variables. But I'm introducing the idea of global variables because global variables kind of lend themselves to the idea of object-oriented programming later. If I define these up here as global variables, I don't have to pass in parameters. And I'm not saying that's a great thing. I'm just saying that that's a side effect of declaring them globally. Why is temp F underlined? Oh, because I don't need to pass them in anymore. I deleted them, right? Okay. So here's our function again. And these variables are being shared. If I change the value of one of those variables in here, if for some insane reason I say that, oh, by the way, temperatures C is equal to 999, then by the time I get back here, if I printed out temperature C, after the output function was called, it would now have that new value. So that's kind of the danger of global variables, is that if you change the value in some function, that value change is going to hold true everywhere that that variable is used. Now, is that a bug or a feature? Well, it's just a thing. It's the way it works. And so if you're working with another programmer who decides that he can change the value of your global variables and you don't know about it in the code you're working in, then your code's going to get broken. All right. Now let's go back to the idea of namespaces. And you're right, we could have passed these parameters in as pointers rather than parameters. A pointer is a special kind of parameter that gives you direct access to that memory. The way we passed these values in a minute ago, the values were copied in. We passed in 1,500, so the value 1,000 got passed in and filled into that, and the value 500 got passed in and copied. That's called pass by copy or pass by value. There's another mechanism for passing known as pass by reference, which is where you give, forget that. I'm going to talk about that later. Pointers, just remember that pointers are another way of passing data into a function, and we'll explain what they are. Namespaces. I could do this. Namespace my data. I'm putting this in all caps for I have no idea why. There we go. Remember we said this was like a sofa? We put the sofa outside. Now we've moved the sofa into a pool house called my data. Every house can still go out and use that sofa if we want to, but we have to say where the sofa is. We have to do this. We have to go over here and do my data : We're still using global data. And we're having to change it everywhere. Everywhere those global variables are used, we have to specify the namespace that they're in. Now, I have said previously that there's a way you can avoid having to type like std : in front of a whole bunch of things. What keyword, what syntax did we use to stop from having to type std : cout? It was this using namespace business. With this line here, we do not have to put std : in front of cout. If I comment this line out, I have to go and fix every reference to std, to every reference to cout, cn, endl, and a whole bunch of other things. Okay. That kind of implies that if I had not wanted to put my data : in front of all these references, if I thought that was quite wearisome, I could have avoided doing so with this keyword. I could have done this. Using namespace my data, then I would have been able to skip typing that. It's not an error to leave it there, even with that using namespace. We're getting closer to object-oriented programming in classes by sticking our global variables in a namespace. So promise me that if you go out into the wild, you get a job doing this stuff and you start using global variables, put them in a namespace so that your boss and coworkers won't come and make fun of me. Global variables are not considered really a totally good thing because once declared, anything could change them. Any other program, any other .cpp file in the project has access to that global data. So at least by sticking it in a namespace, it becomes very obvious where that data is located. And this namespace probably ought to match the file name in some fashion. Okay, I'm going to, get rid of this line. Now I'm going to have to correct the namespace references. I'm going to go ahead and comment that one out so that I have to leave that std : there. For these programs that I asked you to write, I don't care if you declare your variables as local or global right now. If you have the idea of local variables and you want to stick with it, that's totally cool. If something seems to make sense that you'd want it to be shared between more than one function, well, as long as we're writing code that just has a main method, we only have one function, so there's absolutely no benefit to making data global. But you could. All right, that is rather off the idea. C++ keywords. These are the words that define the language. You can be a C++ programmer and never see some of these words. There's a lot of them. It's a large language. On the other hand, there's nothing wrong with sitting there and Googling up every single one of these words and finding out what they mean. And some of them you won't understand, as a beginning programmer. But some of them we do know already. We've used int already. I think we've used if statements. We may have demonstrated while statements. Seeing the word or there is interesting because or is represented by two vertical bars. And is represented by two ampersands, shift 7. So I wonder what syntax you can use that allows you to actually use that word and. Forgive me while I test that. I'm going to just create a variable here. X is equal to 3, int y is equal to 4. If x equals 3 and y equals 4, is that valid syntax? No, it's complaining about that. So I don't know what the and keyword does. To get that to work, I would use a symbol for and. All right, anyways, diversion completed. You cannot make your variable names match these keywords. Now, most of the time, you're not going to. Would you want to create a variable called if? I don't know. You might want to create a variable called friend or this. Generally, that's not going to be a problem. And if it is a problem, you're going to know right away. Because say I do this. Say I make a int and I decide that I want to call my integer friend for some reason. It flat out tells me right away this is a problem. And it colors it a different color. In this editor, the keywords are colored blue, unless you go and you change your colors. So, already we know that that's not going to work. But keywords cannot be used as identifiers. We could not make a method called friend either, I believe. Let's find out if that's true. I'm going to make excuse me, I called it a method. It's a function. We cannot make a function called friend, I believe. Yeah, because it's a keyword. C++ wants a guarantee, and it does force itself to know that every time it finds one of those special words, that that's actually part of the language and not something you created. So your identifier naming rules. Can't start with a number. Can include letters, underscores, and dollar signs. Cannot be a C++ keyword. And what are identifiers? Programmer chosen names. Chosen for variables, functions, and classes, and methods, and members. That's all object-oriented programming terms that don't mean anything to us yet. A method is a object-oriented function. So sometimes I will slip up and call something a method when it's really a function. If I say method, just pretend I said function at this point. I'll try not to make that mistake. Okay. Variable names should represent the purpose of the variable. It's better to have a long variable name than just a one-letter variable name. But up here, I'll often say int x is equal to 3, int I is equal to 10, just for demonstration purposes. But if you're writing real code and you want to allow the user to type in the number of items that the person ordered, it's way better to call that variable items ordered than just to call it I or IO, you know. Make your program readable to somebody else. If you printed out your program and handed it to them, they ought to be able to look at the variable names and have some clue as to what's going on, unless the topic is just so arcane that even knowing what the words, you know. Anyways, single letter variable names are bad. About the only time you should legit use single letter variable names are for counters. You know, if you're going to count from 1 to 100, X is as good as using the word counter, honestly. But beyond that, you should use whole variable names. This is known as camel case. I may have mentioned this already. It's when you leave the first letter uncapitalized, but if you tack on multiple words, like I love the German language. The German language, to make a new word, they just tack on old words until, you know, they come up with something that's like 40 letters long. You can do that with variables names. You know, this could be items ordered in May. But this is camel case. It's got a hump in the middle. That hump is a uppercase letter. Every new word you tack onto your variable name should be uppercased, capitalized. So items ordered in May would have a capital O and then a capital I for in and then a capital M for May. I guess people started doing that around in the 90s at some point in time. Before that, there were other rules that people followed. There is a naming convention called Hungarian, which Microsoft used because it was invented by their head programmer at the time, who was Hungarian, and so people made fun of his naming nomenclature by saying it was Hungarian variable names. And you'll probably see those in books sometimes, and it's considerably different. Identifier rules. It must not be a number, so it can be a letter or an underscore or a dollar sign. For some reason they leave out dollar signs, but they can be. After the first character, you can use alphabet, numbers, or underscores, or dollar signs. Upper and lowercase characters are distinct. So if I go into my code and I say here I was using tempf. If I try to use tempf without capitalizing it down here, my data : tempf without capitalizing it, that's going to be a syntax error because it has to match exactly, including case. And as I wander around and help y'all type these things in, a lot of the problems are going to be things like sometimes you type the word temperature with a capital T, and other times you type it with a lowercase t in a different part of your program. And that's just a learning thing. You'll learn. Has to match exactly. One way of learning is to always make all of the letters lowercase, or to make them all lowercase except for the beginning, you know, of each word after the first. Some people do this. Instead of doing items ordered, a very popular style in the 80s and before that was items underscore ordered. If you think that looks better, that's totally cool. Just be warned that it's considered older-fashioned than to do it that way. And you can't mix them, of course. Once you declare items ordered like that, you have to use that exact spelling of it. You can't then go and change that to 1. There are evil things you could do, like confuse lowercase l's and 1s in your variable names. You could declare one variable called xl and another variable called x1, and then you could make these variables very important. Don't do that. Don't make variables that are confusing to look at. So I try to avoid lowercase l's completely in my code. So if I want to make a lowercase l, or if I want to make a variable called list, or just L, I'll actually make it uppercase L, just to differentiate it. Other things that look alike are zeros and O's. A lot of programmer fonts at least put a line through the zeros to differentiate them so that you can tell the difference. It's easier to tell the difference between these two, and those two. Alrighty. It's too bad they already have the answers here. I guess I should have made up my own. This is what I get for using the instructor slides, I guess. This is a valid variable, so we don't have to fill in a reason it's invalid. This is a valid variable. It's got an underscore in it. Excuse me for these red underlines. Is this a valid variable? It could be if you had an object named total, but just as at this point in time, we'd say it's an invalid variable. Why? Because it's got a dot in it, and dot is an invalid character for a variable name. Is this valid? No, because it starts with a number. Is this valid? Yes, it is, and it says it's not. The text is pretending that dollar signs are not valid. We can prove them wrong. Whatever. But almost nobody uses dollar signs, and if you put them in your code, then people are going to raise their eyebrows and not quite understand what's going on. They may think that it means something. In old versions of BASIC in the 70s, you used a dollar sign to declare a string. So if you ever saw a dollar sign, it was a very different variable than a. It meant something completely different. The dollar sign actually did something. But in C and C++ and Java, it does not. It's just another letter you can use. So if you want to throw dollar signs into your variable names, go ahead. Just realize that some people will be confused when they see them. Integer data types. Because C and C++ have been around since like 1970, then there have to be like 40 different integer variable types. Whereas if you use a more modern language, and modern is not meant to say that it's better than C++, it's just a fact that it was invented more recently, and so they've cleaned it up. A short int is defined as being 2 bytes, but notice it says typical. Somebody could write a C++ compiler that said that a short int was 1 byte. Or they could say that a long int was 8 bytes. Typically, as computers get larger with larger amounts of memory, then these tend to wander. Back in olden days, an int may have just been 2 bytes. And then it migrated, and then it migrated again to be, maybe it was 3 bytes later, and then it was 4 bytes later. So in the language that we're using now, and in modern C++ languages, these tend to be the standard, is that an int is 4 bytes long. And a long int, I believe, is supposed to be 8 bytes long, but it says that it's 4 bytes long. A long int, isn't it silly? Long. Has twice as many bytes as an int. Am I going to make you memorize this? No. But just know that if you're using an int, it can hold a number between -2 billion and +2 billion. If you need to use a larger number, something that goes up larger than 2 billion, you're going to have to use a long. Sorry, I know that's silly sounding. I'm going to use a long as opposed to a short long. Anyways. If you tack the word unsigned on it, it means that the number cannot go below 0. But that gives you twice as large a maximum number. And did I get up here and draw zeros and ones and show that the sign bit could be used to make something negative or positive? Not seeing any nods. You're going, yeah, I know that because I took your class before. But suppose you have 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. Well, what are the places involved? That's a 1, 2, 4, 8, 16, 32, 64, and a 128. If we added all those together, this adds up to 255. So 8 bits can hold from 0 to 255, which is 256 different possibilities. This is the max. But this kind of skips the fact that you might want negative numbers. You might not want 0 to 255. This is what's known as an unsigned byte. It's unsigned because it's always assumed to be positive. If you want to store negative numbers and you still want them to be limited to 8 bits, then you have a little bit of a conundrum, which is solved by making the first bit a signed bit. And so now you have a 1, 2, 4, 8, 16, 32, and 64. But this one has a special meaning. So if all of these were 1s, then you have 64 plus 32 plus 16 plus whatever, that equals 127. So these bits here can count from 0 to 127. When you set this bit, if it's a 0, it's considered positive. So that number right there is positive, 127. But if you set this bit to a 1, it's treated as a negative number. And you'd think it would be negative 127 because all that changed was we went from positive to negative. But due to a little bit of, well, it's actually negative 128. And I'm not going to explain why. Yeah, I will explain why. What if you have 0 followed by 7 zeros? That's equal to 0. What if you had 1 followed by 7 zeros? Well, that's negative 1. Okay, no, it's not. Yeah, you got it. Because there's, no, excuse me. That's negative 0, right? Because these are all zeros. And we just made it negative, but there's no such thing as negative 0. So this is actually treated as negative 1. So you actually get one more number out of the range when they're negative than you do positive. So here, by having a sign bit, we still have 256 different values because negative 128 up to 0 and then up to positive 127 is a total of 256. So if you have unsigned, you can get a larger maximum value at the price of not allowing negative numbers. If you have signed, then you get negative numbers as well as positive numbers, but they're only half as large as the maximum. It goes up from 127 down to negative 128. So if you want to force your data to always be positive, or you think you need larger numbers, did we start at 8:30 and it's actually 9:40 already? Whoa. We were having way too much fun. Y'all got away without getting any homework. Shame on you.
Just for Labor Day, too.
Yeah. All right. Just sign your name. As soon as you sign, you can bail. And I'll see y'all on Tuesday. Unfortunately, Labor Day doesn't get us a day off.